My talk today is about bypassing HTML sanitizers with parsing differentials. And if you have never heard anything about parsing differentials, that's perfectly fine because I will go over this in my talk, obviously. First, a tiny bit about me. I'm a PhD candidate. I work in Germany at Technische Universität Braunschweig, and I'm funded by Casa. And as there probably won't be time for questions, I have some Casa plushies to give out to anybody who basically approaches me after the talk and has an insightful question. I'm doing research in web security. That's why I'm presenting here about basically HTML sanitization, but I'm also interested in privacy and application security. And when I say application security, what I mean is basically I try to do stuff where basically we have an insecure application because like it's a legacy application. People may not even have the source code anymore. And we try to basically make them secure without the developer having to do anything about this. Because that seems like a good idea because security has gotten so complicated that the average developer probably doesn't have any time to keep up. And this basically leads me to the talk today, where we basically try to something fairly different, similar. And to understand this, I assume most of you know cross-site scripting, but some people probably are not overly familiar with it. I will briefly explain cross-site scripting, how it works. And basically, in the web, you have at a lot of points, pieces of information which basically come from the user, like from the URL, for example. That's a typical case because you can trick people on clicking on some dangerous URL and have some phishing email, for example. That's pretty easy to do, and yeah, phishing is still super popular. And as soon as you have user input in your application, this works obviously on the client on the server side, there are certain functions which basically will reflect this input back to the user. And they look fairly benign, but what they effectively do is it's like calling eval on the user input. And if you do like Python programming, everybody knows calling eval on user input is a complete train wreck. However, in the web, such coding patterns are everywhere. There are so many functions which basically do implicit eval, which basically permanently take text and transform it into code. Because on the web, there's basically zero distinction between what's data and what's markup. And markup can always execute like JavaScript code. And if you can execute JavaScript code in the session of another user, you can do all crazy stuff like stealing their authentication cookies. You can exfiltrate data like stealing credit card data and all stuff. You can basically impersonate the user and you can impersonate the website and exfiltrate all data. Like cross-site scripting is a really big problem. And cross-site scripting is often linked to be like the memory corruption of the web. It's like the most popular, most common vulnerability class we have today, together with memory corruption. And at least for memory corruption, we seem to get a handle on it with language like Rust. Cross-site scripting is still here to stay, sadly. So just an example for a website which obviously does this, it's if I basically open amazon.de, I'm greeted with hello David. And David is a piece of information I provide to this website. So they're reflecting user input back to me. And if this was not programmed correctly, this could basically, for example, have a cross-site scripting vulnerability. However, most websites which were popular had cross-site scripting vulnerabilities, even Google in their search bar not that long ago, but that's not the case all the time. So people are apparently defending against this. And basically to make this relatable, where a website allows you to basically input HTML, and this is the main topic here. If you want to basically say it can only be text, it's easy to achieve, but sometimes you want to allow your users to have some formatting instruction to basically make something bold or emphasize text. That's perfectly sensible, right? In academia, everybody uses Hotgrep, which is this tool where we submit papers, and the same as the Black Hat CFP tool, for example. And here, if you run a conference, you can basically insert HTML. If you can insert HTML and the sanitizer is not, or it's not perfectly protected, you can usually get cross-site scripting, and this is usually demonstrated with this alert box above. And how would you defend client-side or cross-site scripting? On the client side, it's fairly easy. You can use dynamic taint tracking like a taint browser. There's a very good taint browser. I'm a maintainer of Project Foxhound. If you're interested in that, please get in touch. On the server side, it's less clear because the flows are way more complicated than the one I've shown. And we don't, as a researcher, I don't have access to any closed source software, obviously. And I thought, how can I still basically manage to protect closed source software? I look at the protection mechanisms because they all employ protection mechanisms. And the main way basically protect against cross-site scripting is to use a sanitizer. And the core idea of the sanitizer is super simple. You simply remove or change dangerous parts of the inputs. And basically, you want to allow a tag which makes text bold, for example, or emphasizes stuff. This should be passed through. But if you have a cross-site scripting payload, like the image tag shown here, if the source X doesn't exist, X is not some URL that is retrievable, then the on-error handler is called and this alert box pops up. And you obviously don't want this because the hacker wouldn't use alert, but they would basically steal your data. And what the sanitizer would do, it basically would simply remove this on-error tag so that only an image is shown, and that's safe, right? So this is called sanitization, and the definition of a sanitizer is that we have a function which takes arbitrary input and returns a safe value, which basically is free of any cross-site scripting payload. And there's a functional requirement as well, and that the output should resemble the input in the sense that it should preserve the benign parts. Otherwise, you could simply return empty string. This would be secure, but the website would be completely pointless because all the dynamic data is gone suddenly. And how did I come to this research? In 22, I was researching with a friend of SAP, basically how people would try to sanitize if they wouldn't use an actual sanitizing library and basically try to filter HTML with regular expressions. And we found stuff like this, where people would say, yes, if I remove the alert keyword, then no alert boxes will pop up, but yes, the real hacker wouldn't use alert. So we found a lot of really crazy stuff, which basically exactly how not to sanitize HTML. And why I'm telling this story is, after we basically concluded this research, my takeaway was, yes, parsing HTML with regular expression, if you have paid attention in your computer science class, or the developer would have, they would know it's not possible. But if you use a real HTML parser, basically, the parser would assign meaning and understand what the input actually means, and then it's fairly easy to do sanitization. And most server-side sanitizers actually do this, and all the good client sanitizers as well. But over time, I thought further about this, and the question arises, did this really help? And it turns out, no, not really. Otherwise, I wouldn't be here. And to understand why there are problems, and like to introduce the parsing differential concept, I will quickly explain how a sanitizer which uses an HTML parser works. You have input, which is text, and the parser would basically turn this text into some abstract representation. And in the web, an abstract representation is always basically in this tree form, because in the end, the website is also in a tree form, like the document object model tree. And here we, for example, have this node in red, which is dangerous, and then the sanitizer does a cleanup phase and basically removes everything that's dangerous from the DOM tree, and then basically turns it back into text because HTTP is text-based, and sends it to the browser, and the browser will then process it and render a website for you, for example. Okay, if you have basically followed a lot of security talks in the past, you will see there's a coding pattern which is always dangerous and always prone to vulnerabilities. And this coding pattern is that we have basically two parse functions for the same basically input language, but in different programs. And what can happen is they could disagree, for example. What if they assign to the same input different meanings? And can we abuse this? And why, if I assume everybody here has written some HTML in some capacity, and HTML looks really simple, but parsing HTML is actually really not simple. And I will just go over a few quick examples why that is the case. For example, if you have an SVG tag, the parsing will change to an SVG parser, which has the same syntax, but the elements will get basically assigned different meanings. The semantic of some text will change. If you have like incorrect HTML, for example, here we have a div tag inside a table, the browser will say, yeah, that's not valid, but I know what you actually meant. The div tag probably should be before the table because it's perfectly sensible. Everybody knows that if you have a div tag in the table, it should be in front of the table. It makes perfect sense to me. No, it does not, but that's how the standard works. So basically, the browser will rearrange these inputs, and this is called a mutation, basically, because in the parser, the basically input will get repaired and changed. You have some text where opening tags are closed automatically, and if you have a closing text, that's transformed to an opening text. You have text like the image tag, which have script execution capabilities. And you also have text like style, which change the parsing mode, like everything below style is parsed as text. And this is like a very short excerpt of all the basically parsing issues we have. There will be some more in the future, or in the remainder of this talk. And what I want to highlight here is that HTML looks really simple as a language, but it's really difficult to parse. And if something's difficult to parse, you always have the basically possibility that you get some parsing differential. And the parsing differential basically works like this. You have the first parser, which basically says, yeah, that looks perfectly secure, but simply echo back the input. And the second parser says, yeah, but it means something completely different. For example, here we have this red node, which is some dangerous node, and the browser would execute JavaScript. And this might sound a bit abstract. So yeah, basically the sanitizer and the browser disagree in what the parsing means. And I walk you through a full example basically to show how easy it is for such mistakes to creep in. And for example, if you look at the following payload, which is fairly simple, I would say, we have a select tag. Inside the select tag is an iframe tag, and inside the iframe tag is a script tag. And if you parse this with Google Kaya, which is a sanitizer which was written by the Google guys, you would get the following result, like a select tag followed by an iframe tag, and inside the iframe tag, there's a text node with the script stuff inside. If you pass the same input, and Kaya would basically return it unchanged, so if you pass the output of Kaya in Google Chrome, you would get a select tag, and inside the select tag, you have the script tag, which executes JavaScript code. So that's not great, because apparently there's an issue that Kaya doesn't understand this payload correctly. And I will explain why, and to do this, I will basically start from inside out, and first look at the iframe tag. And in HTML, this is fairly well standardized. There's a huge specification, like 1.5K pages. Each element has an element specification, which is shown here, and a parsing specification. And the element specification for the iframe element says, has a content model. And the content model always describes what can be the child nodes of an iframe tag. And here we have nothing. And what does nothing mean? Exactly what it says on the tin. Basically, you can have no text nodes and no other element nodes. However, if you look at the parsing specification completely disagrees and says, yeah, content of iframe shall be parsed as text. Okay, that's not great. It's an inconsistency in the specification, basically, which is one of the lot of issues we identified. And if you try it basically out and do something like this, you basically test it, and you see this will result in an iframe element where the payload is a text node under iframe, exactly like the parsing specification says. It's simply the element specification being wrong. So in this sense, the sanitizer is correct because it passed the input correctly. But if you think again what Google Chrome puts out, the iframe is actually gone. And why has this iframe? Is this iframe gone? This seems a bit strange. If you look at the payload again, in front there's a select tag. So we do the same for select tag again. It also has a content model, and the content model of select says 0 more option, opt grouped, or script supporting elements. Script supporting elements sounds a bit particular, but those are basically script tags and template tags for some reason. So what this basically means is that an iframe tag can't be a child of a select tag, and Chrome will simply say, yeah, that's invalid, I will delete the iframe for you. You probably made a mistake, I will fix this up for you. And this shows how easy it is, basically, if you write a sanitizer, to basically overlook one of those small things and basically then end up with vulnerability and then some hacker is basically able to basically circumvent your sanitizer. If you know a bit about Google Kaya, Google deprecated this like 5 years ago. However, this doesn't stop companies from using it. I've looked a bit around and I found deployments by Adobe, and if any here works for a company using SAP and hasn't updated in a while, I would certainly recommend doing so, because SAP has this UI5 toolkit, which is basically powering all the web applications. They were using an insecure version of Google Kaya. This has all been fixed, so everything we have reported has been fixed. So if you have updated, you're secure. And so what I thought, these parsing differentials are really interesting. HTML is so complex that nobody can get it right, basically. Can we find those automatically? And other people have done this manually. There are a lot of blog posts from super smart people, but I'm a computer scientist, like I'm a lazy person. Why don't we do this automatically, right? So I wrote basically a payload generator, and the idea is to generate basically HTML, which is difficult to parse, which abuses a lot of these edge cases, like the stuff where the browser has to repair it. So the idea is that it has to mutate during parsing. Consequently, the bugs I found are roughly in the category of mutation XSS. And what's really important to keep in mind, and that sets HTML apart from basically every other programming language, I would say, is that, for example, in Python or JavaScript, if you make a syntax error, the parser will complain and basically abort the parsing process. In HTML, that's not the case. HTML parsing basically can't fail. If there's a single angle bracket in your input, then the browser will render something for you. Whether that makes any sense is unclear, but it will render stuff. So basically what you could say is garbage in and you get website out. And that makes it really easy because the input can be completely broken, basically. And then basically what we tried to do was to make a very abstract representation how we could basically build up a payload and then translate it back into basically script text form. So we basically could then test it in all different browsers like Chrome, Firefox, and Safari. And for example, the payload shown here is one of the most successful one because no script is impossible to parse on the server side because it relies on some browser features which are not exposed via JavaScript, for example. And yeah, having a fragment generator is nice. We wanted to test it, and we tested it across 11 sanitizers, across 5 programming languages, and you can see it's like popular programming languages, Java, JavaScript, PHP, Ruby, and .NET. So a lot of big websites are written in those languages. And if you basically look at the sanitizers we looked at, or that's a bit broken, if you're in the web security field, you will probably recognize some names like DOM Purify, or for example, Antisami, which is an OWASP project, Typo3, which is like the German WordPress. And what we can see is basically besides Sanitize HTML and Loofah, all of them basically have vulnerabilities. And in total, they have over 1 billion downloads. So it's not niche software, but it's software that's used everywhere. Like most big websites use DOM Purify in some sort of capacity. And when I first started mutagen, I was greeted like 10 seconds with a message like this. It's like index out of bounds read for a string in PHP, and this means nobody has ever tested this program properly before, and this is like perfect for basically bug finding. And what we found was that they all have basically functional deficiencies, even the ones which basically didn't have any security vulnerabilities. And when I say functional deficiencies, I mean they basically destroy benign input. They basically violate this functional property that the output should resemble the input. And we basically came up with a metric to compare the parsing accuracy compared to a browser, for example. And we found across the board it was always below 60%. So the parsing results are really different from the sanitizer compared to a browser. So even if it's not insecure, basically it breaks your input. And we also found 60 new bypass vectors across 9 of the sanitizers we tested, and even 1 bypass vector in a sanitizer we didn't actually test at all, because the OWASP guy were nice enough to basically assign a CVE for us because they transferred our payload. And why is this so difficult? we have these quirks, but you could think, yeah, that's possible to implement. But what you have to keep in mind that the browser has basically two parsing modes, fragment and document parsing, which behave differently in some cases. For example, fragment parsing happens if you do an HTML assignment, and document parsing is if you load a page or have document write, like in the example in the beginning. And certain aspects will basically change if you use one parsing algorithm or the other. Chrome has even more parsers for basically performance reasons. And a second question is, which browser will the result actually be displayed in? HTML is standardized, but that doesn't probably mean they all agree. And I've brought you an example. This payload is basically like this. And I would like to ask you a quick show of hands. Does this execute JavaScript code? Okay, there's no right answer. The answer is it depends. For example, if you basically put this in Google Chrome, you will get the following, which is basically perfectly benign. An SVG tag, below embed, iframe, and everything below under iframe is text, like I've shown before. That's correct. If you have it in Firefox, you get something like this. And this basically means, Firefox never terminated the SVG namespace, and the image tag is the only thing which basically closes the SVG namespace and executes JavaScript code. So you basically have to be aware which browsers are users using, and none of the sanitizers which are actually tested have any way to basically communicate this to the user. And this is an open bug in Firefox. I'm basically fighting them for 2 years that they might want to fix this, but I was not successful so far, despite having good contacts to the Mozilla guys. What this also means is that basically having a perfectly accurate sanitizer is impossible because you don't know what your user browsers are using. There are certain tags which rely on stuff that's not exposed even inside the browser, so you can't know it on the server side anyway. And this leads to some problems because it effectively means that server-side sanitization simply doesn't work, basically, because if you can't parse the result properly, you will always have room for parsing differentials. What we also found, and this is really interesting, if you basically run a successful website and ask security experts what you should do, they always say defense in depth, because every defense mechanism might be broken, and it's basically perfectly sane advice. I don't want to say anything bad about defense in depth, but sometimes this can go wrong, like everything in life can go wrong. For example, if we have the following input, which like is an SVG tag, followed by a style tag, followed by an escaped image tag, followed by a keygen tag. The keygen tag is kind of strange because it has been removed from the HTML standard like 15 years ago. Firefox has even completely removed it. It's one of the only things that have ever been removed from the web, I believe. However, DOM Purify outputs the following. The keygen tag is gone. That doesn't really matter, but the image tag has been unescaped. So this is suddenly a dangerous payload. The initially benign payload was turned into something that will execute JavaScript code. And this can basically, for example, be used if you have a web application firewall in front of your sanitizer that basically this benign payload passes through the web application firewall because it would never execute JavaScript, and DOM Purify turns it into something that will execute JavaScript. So basically, Sanitizer turns benign input into dangerous output and helps you circumvent defense in depth mechanisms. So there are a lot of issues with sanitization, basically. And I will go over some common problems. If ever anyone would want to write a sanitizer, I can not recommend this. Handling comments is apparently extremely error-prone. Like 3 sanitizers in the test set didn't detect closing bank comments. That's comments terminated with an exclamation mark. No script is impossible to get right because it relies on whether the browser supports JavaScript, and this is not exposed anywhere. And simply basically being able to use JavaScript doesn't mean that the JavaScript scripting flag inside the browser is on. So if you have encounter no script tag, you're basically completely unable to parse it. It's impossible to get right, basically. Exactly, it depends on internal state not exposed to sanitizer, so sanitizing inputs which contain the no script tag is basically impossible. Namespace confusion bugs are also really common. Namespace confusion bugs is basically if you have text which change to, for example, SVG or MarsML, which is a different way. You can embed a different language inside your HTML code, where you can basically typeset mathematics. And for Sanitizer also, it's really difficult to basically keep track of this namespace. And I can understand why the rules are fairly complicated. And even the browsers don't get it right. Like the Firefox example before was also namespace confusion bugs. And we found some insane fundamental parsing bugs where basically some text, if you don't have a close and angle bracket, would be terminated automatically for you for some reason I can't figure out actually. Yes. Thank you. That's from my side. If you want to chat web security, client side or server side, please get in touch. I'm here till tomorrow. And basically, those are the sound bites and basically sum up the presentation. And yeah, apparently, we still have 4 minutes for questions. So if there are any questions, I'm super happy to take questions. And if you have a question, please go to one of the microphones.
Hello. Yeah, you talked about the concept of parsing differentials in different browsers. At a high level, then, the problem exists because all of these browsers have a different implementation of parsing, right? So as an industry, if we're going to look at fixing this or making it less common, then is there a need for some kind of shared parsing functionality that all browsers would use?
Okay, the question is whether a shared parsing library would fix this issue. I believe that would be a good idea. Even the reference implementation where you can test your parser against is a good idea, I would say. I don't believe this will ever happen. Like, for example, I know the Mozilla parsing code, and that's completely insane. They would greatly benefit because they have a Java program which generates C++ code, and this is a parser in the end. That's completely crazy. But having like a general parsing library which all the browser vendors basically maintain together would fix this problem to some degree. For the Sanitizer, it would not, but it would get rid of browser parsing differentials because the Sanitizer would then have to use this library, and not every language basically will be able to interact with that. And you have some text like NoScript which depend on runtime state. But it would be a good step in the right direction, I would say. The only other basically fix I could think of is basically making a strict mode for HTML where you can opt in and then the parsing changes. But that sounds like a proposal I wouldn't want to make because it's getting something in the web or standardized is so much effort. I know people who do this and they complain every time I have to speak to them.
Hello. As a defender, what will you recommend we do? Should we blacklist or whitelist a certain node type, or what's your recommendation?
The recommendation, or the question is what I would recommend for defenders. Personally, I believe HTML sanitization is a huge anti-pattern. You should never basically allow your users to input HTML and basically try to filter out some text, because this will never work properly. Super smart people will always find bypasses. What works better, I would say, is, for example, use a language like Markdown if you want your users to be able to format text and then convert that to HTML, because it's a way smaller text surface. And that's basically an approach which a lot of websites started to follow. And that seems like the right direction for me. Never allow users to input HTML, and then a lot of the issues will be gone, I would say. Okay, if there are no questions anymore, the timer tells me the time is up. Yeah, thanks for your attention. Thanks for having me.